Welcome back. In previous lecture, we have started the turbocharger. So in previous lecture, we have discussed about the definition of turbocharger and different methods of turbocharger. So in previous lecture, we have discussed about constant pressure turbocharger and pulse turbocharger. So this constant pressure turbocharger have some advantages, some disadvantages. Again, the pulse turbocharger also have some advantages and disadvantages. So if you eliminate the disadvantages of both these systems, that is constant pressure system does not give a quick response and pulse turbocharging system is complicated if the number of pipes are more, that is number of cylinders are more. So to reduce these disadvantages of these two systems, one system is introduced and that system is called as pulse converter turbocharger. So this pulse converter turbocharging nothing but what simply the combination of these previous two systems, that is constant pressure system and pulse turbocharging system. So in this pulse converter turbocharging, as name indicates, we have to convert the pulse. That means pulse means what? Kinetic energy. That convert into pressure energy. See the diagram. So 1, 2, 3, 4, these are the number of cylinders. From that exhaust pipes are connected to the converging diverging part, that is called as what? Venturi. At the mouth of the venturi there is a nozzle. So when these gases comes into this convergent divergent part, we know as the part is convergent, its velocity increases and pressure decreases. And when in divergent part opposite action takes place, that is kinetic energy decreases and pressure energy increases. So in pulse converter turbocharging system has the advantages of both constant pressure and pulse turbocharging system and avoids drawbacks of both by connecting the different branches of exhaust manifold together in a specially designed venturi before entry to the wall. So this venturi junction is called pulse converter. So pulse converter turbocharging system has the advantages of both constant pressure and pulse turbocharging system and avoid the drawback of both by connecting the different branches of exhaust manifolds together in a specially designed venturi junction before entry to the turbine. So if you see the diagram, that venturi is a convergent divergent part. So in convergent part acts as a nozzle and that divergent part acts as a diffuser. So this venturi junction is called as a pulse converter. The exhaust of engine cylinder from exhaust manifold is joined in a venturi section. The pressure pulse is converted into kinetic energy in the nozzle section because at start there is a convergent part, so it acts as a nozzle. So whatever the exhaust gas enter into this venturi, the kinetic energy of this exhaust gas increases. So it creates a suction effect in exhaust line and helps in scavenging process of engine. So as this exhaust gas comes out with high velocity, so it creates a suction pressure, that is induction effect over these exhaust manifolds. Due to that, whatever the residual gas present inside the engine cylinder that get absorbed and the scavenging process is fast or complete scavenging maybe takes place. So whatever the drawback of this constant pressure system, that is scavenging difficulty, that overcomes with the help of this pulse converter system. So in diffuser part of the venturi, the pressure gradually increases and high pressure exhaust is supplied to the turbine. So in venturi, after the conversion part, there is a diversion part. So in diversion part, kinetic energy decreases and pressure of the exhaust gas increases. And that high pressure gas is supplied to the turbine. So as the pressure is mover at inlet to turbine, the turbine efficiency increase, that is pressure ratio increases. So this system is suitable and efficient even at park load conditions for low pressure ratio turbocharging. It provides very good response in case of sudden change in load on the system. So what are the drawbacks of the previous two systems? These two drawbacks are eliminated, that is scavenging problem. After that, quick response in case of sudden change. What are the drawbacks? All these drawbacks are eliminated with the help of this pulse converter turbocharger. Why this system is called as pulse converter? Because in this case, pulse, that is kinetic energy, converted into the pressure energy. So with the help of this conversion diversion part, hence this system or turbocharger is called as what? Pulse converter turbocharger. Now, limitations of supercharging in SI engine. Okay, we have to use this supercharging for performance enhancement. Okay, with the help of supercharging, we have to increase the charge density, and as the density of charge increases in case in the engine cylinder, automatically the indicator power, that is IP, which is developed inside engine cylinder increases, and from that power output increases. But this supercharging have some limitations in case of SI engine. So we'll discuss why the supercharging is not preferred for the petrol engine, that is for SI engines. So in case of SI engine, the knocking tendency increases with the increase in pressure, temperature, compression ratio and density of charge. When the pressure, temperature or compression ratio increases, in case of SI engine, auto ignition tendency of charge increases, and if the charge gets auto ignite before the main injection or before the main ignition start, then that phenomenon is called as what? Abnormal combustion. That is called as what? Knocking tendency. We will discuss in details in next chapter, that is what is detonation and what is knocking. So in case of SI engine, there is a limitation for supercharging. We cannot increase mover pressure due to the knocking tendency. The compression ratio in SI engine is limited from knock and detonation considerations for a given octane rating of the fuel. Same, we cannot increase the mover compression ratio in case of SI engine, because as compression ratio increases, pressure temperature inside engine cylinder increases, and as the pressure temperature increases, auto ignition tendency of the charge increases, and that is nothing but what? Knocking tendency or detonation tendency increases. So due to this reason, this supercharging is generally preferred for the compression ignition engines, not for the spark ignition engine. But in case of compression ignition engine, that is for diesel engine, supercharging is preferred because the factors which tend to increase the detonation in SI engine, the same factors tend to decrease the knocking in CI engine. For this reason, the supercharging or turbocharging is generally preferred in case of diesel engine, that is compression ignition engines, not for the spark ignition engine. In case of CI engine, supercharging improves power output, thermal efficiency, and it can use inferior fuels with low cetane rating. So this is about supercharging and turbocharging.